Hi everyone, I am Chok Shuying with metric number of MH16053. Our subject is BMF 4873 of Railway Technology, and the title of our presentation is Dynamic Braking System for Train and Calculation. We are from Group 5 and we have 5 group members which shows below. I will start with introduction of dynamic braking system of train. Dynamic braking is the method of train braking with DC or AC traction motors. A conventional electric train braking system uses dynamic braking where the kinetic energy of the train is dissipated as waste, mainly in the form of heat. While the train is coasting, the engineer using a controller similar to the throttle energizes the traction motor fields, causing the motors to act as generators. The resistance of the motor field acts as a brake on the locomotive, which in turn helps to slow the train. At the same time, the electromotors generate electricity to be returned to the power distribution system. This generated electricity can be used to power other trains within the network or can be used to offset power demands of other loads such as lighting in stations. Next, dynamic braking is a supplementary system that provides an additional means of train speed control. Initially, dynamic braking was seen mainly as a tool for mountainous territory. Diesel locomotives for trains operating in level territory, relatively light trains like passenger trains and slow movers like yacht engines did not have dynamic braking. There are three types of dynamic braking. The first one is air brake system, which apply by pushing down the brake pedal. The harder you push down on the pedal, the more air pressure is applied from the storage tanks into the brake chambers. Next is the electro-pneumatic brake, which controlled by the driver's brake valve handle. It is usually the same handle used to control the air brake. The last one is regenerative dynamic braking. The kinetic energy is converted into electric energy and then fed back into the supply system. It is used on all modern electric trains.
Okay, I will continue about the dynamic braking system for train. And the subtopic is the air brake system, which is used widely in the all railway system in the world. It replaced the traditional handbrake system, which is very dangerous to stop the heavy and fast train. So for that, I will introduce myself. My name is Ahmad and entry ID is MH16031. So this is the schematic diagram for the air brake system. Okay, this is the triple valve in detail. So this is actually for the emergency application. You can just ignore the arrow here. Okay, for that this is a little bit inverted. Okay, first this is from train pipe. This is from train pipe, or we call brake pipe, and then one from auxiliary reservoir. This is the one from the auxiliary reservoir, and then next is from to the brake cylinder and also exhaust. This is exhaust and this to brake cylinder. Okay, first of all, the air pressure comes from the train pipe, because it is connected to the main reservoir. So it comes to the main reservoir and towards the triple valve, and also fill up the auxiliary reservoir. So this is high pressure will push the piston valve towards the right, when the piston valve moves towards right, it will reach the feed groove. Feed groove is a little hole that can supply the remaining air pressure towards the auxiliary reservoir at a slow rate. So when the pressure from auxiliary reservoir, same with the pressure from the drain pipe, it will hold the piston valve to its position, and it will close towards the. It will not moving. It will stay right here. Close. This is grating valve is one system. This is one system. One system will move towards here. Will move towards here. It will close the brake cylinder and also exhaust to atmosphere. Okay. When we want to apply the brake, we release the air pressure from the drain pipe. We release it. When we release, the air pressure from auxiliary reservoir will push the piston valve to left, and then when it push, it opens the valve that closed here before to apply the pressure towards the brake cylinder. And then when we need to release the brake, we just apply pressure from the drain pipe, and then the piston valve starts to move right again, and it will release. As you see here, there is a gap between. It will release the pressure to the atmosphere first before it is closed. So it lets the new air pressure comes from the drain pipe and refill the auxiliary reservoir again. This is how triple valve works.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Faizan binti Muhammad Rauzi. I would like to present my part, which is electro-pneumatic brake. For introduction, the electro-pneumatic, which is EP brake, was introduced in the early year of the 20th century in an attempt to overcome the lag in the operation of the pure air brake. EP brake originally designed for subway or metros. Electro-pneumatic brake systems are now common on mainline passenger railway and on some specialized freight operation. Its main advantage over the air brake is its speed of control and quick on-vehicle reaction times, giving instantaneous control of the whole train to the driver. Principles of the EP brake. There are many types of EP brake system in use today, and most of them were developed as an add-on to the original air brake system, and as a result, incorporated some common principles in their design as follows. The EP brake operates as the service brake, while the air brake is retained for emergency use. The EP brake does not compromise and fail-safe or vital features of the air brake. The air brake normally remains in the release position even while the EP brake is in application and the same brake cylinder are used. EP brakes are invariably used on multiple unit passenger trains. EP brake use a number of train wires to control the electrically operated brake valve on each car. The train wires are connected to a brake valve or controller in the driver's cab. Figure 1 shows a schematic of the pneumatic layout of a simple EP brake system. A main reservoir pipe is provided along the length of the train so that a constant supply of air is available on all cars. An application valve in this connection pipe will open when required to allow main reservoir air into the brake cylinders. The brake pipe is fully charged during an EP application. The triple valve is in the release position, so the brake cylinder is connected to the exhaust. For EP operation, a holding valve is added to the triple valve exhaust. When an EP application is called for, the holding valve closes and prevents brake cylinder air escaping through the exhaust. Okay, next move to electro-pneumatic control. Electro-pneumatic brake are controlled by the driver's brake valve handle. It is usually the same handle used to control the air brake. Electric contacts are provided so that selection of a position will energize the train wire required to operate the EP valve on each car, as shown as figure 2. Current to operate the brake control is supplied from the battery through the control switch, which is closed in the operation cap. That's all from me. Thank you, and I will pass the presentation to the next presenter.
Hi, my name is Mimi and my student ID is MH16012, and today I will talk a little bit about regenerative braking system. First, you need to know what is regenerative braking system. A conventional electric train braking system uses dynamic braking, where the kinetic energy of the train is dissipated as waste. When regenerative braking is employed, the current in the electric motor is reversed, slowing down the train. As applied to rail vehicles and systems, regenerative braking offers two distinct benefits. The first being the consumption of this available electrical energy by the locomotive or train itself, while the second is the ability of the entire system to reuse the generated electricity. There are some advantages of regenerative braking system, such as number 1, reduce energy consumption, number 2, the ability to reduce wear of brake shoes, and number 3, can lower maintenance costs. Meanwhile, for the disadvantages of regenerative braking system are larger motor requires and less effective in DC locomotive. In general, the introduction of regenerative braking on electric trains and subway trains will have no direct effect on the local air quality. However, lowering the electricity demand will lower the emission of air pollutants like nitrogen dioxide and sulfur dioxide. Regenerative braking is a mature technology. It can be more easily applied to AC-powered trains than to DC-powered systems. Besides, employing regenerative braking in trains can help to reduce the air pollutants, which is very crucial to our world nowadays. Thank you.
Hi, my name is Mugadil Asnab, MH16022. From this slide, we will learn how to calculate dynamic braking system. This is the free body diagram how to calculate the braking system. Now, we will load the brake force formula. B is the brake force, m times g gravity. We will get the weight trains, and beta is the typical value is 0.09. For the tractive effort, we will plot graph P against V, and we will get graph like the figure shows. This is a force drag formula, and V is the speed in meter per second. For the acceleration formulas, we mix the tractions, efforts values, and the drag values to find it. Sin theta is the gradient in this equation. Speeds formulas, we also need the traction efforts and the drag values to find the maximum speeds. Beta is equal to sin alpha is equal to the gradients. We need to find the braking distance to measure the distance of the braking. That's all how to calculate the braking system. Thank you very much.
Lastly, the conclusion of dynamic braking system is: in the dynamic braking system, we know that there are three types of dynamic system for train, which are air brake system, electro-pneumatic brake, and regenerative dynamic braking. In braking system, we can calculate brake force, tractive effort, drag, acceleration, maximum speed, and braking distance. That's all from us. Thank you.